Hey everybody, my name is Dr. Allison Justice and I'm here with the CRC PIP Research Center. We are looking at airflow and how it impacts cannabis growing, yield, secondary metabolite production, and we'll even dig in a little further looking at different physiological aspects such as leaf size, um, stem strength, stem size, and further. But right now we're standing in the no airflow, which isn't actually true. It's actually about 20 feet per minute, just due to actual air conditioning. But as far as actual addition from VAS sorts of fans, there's none. So I'm doing it in here because it is quiet. And you can see nice, beautiful plants coming immediately out of the vegetative cycle. Today is Tuesday, but on this past Friday, we flipped flower. These plants look great. You can see the flower formation beginning. Large leaves, which is absolutely something we're able to correlate between velocity and plant growth. And then here in the middle, where there truly is zero airflow, we actually start to see a little bit of tip burn. Now, it's not everywhere on every plant. We're certainly keeping track of this to understand and report back. But you'll see a little bit of leaf tip burning. Now, that's due to higher temperature, right in the 80s, higher humidity, 70, 80%, high nutrient load. And so what's happening is, due lack of air velocity, the plants are forming pretty high microclimates. Plants are wanting to transpire, but the environment they're in won't allow it. So there's actually accumulation of salts here at the edges of the leaves. Here we have the medium airflow treatment. So you can see the leaves are just dancing. It's at 0.5 meters per second, or around 98 feet per minute. The leaves are smaller. The stems are much more sturdy and higher in caliber. You'll see here, right at the height canopy, we have these anemometers. So these anemometers are extra special, a little bit different than handhelds. Many have. For research purposes, we thought it would be important not only to have multiple per treatment, but also to have a multi-directional anemometer. So a lot of the handhelds you have will only measure in one direction, but these will actually measure in multi-directions. Pretty neat systems. It's two pieces of wire together where voltage is sent through those wires. And so as those wires cool, that can actually measure velocity. You'll see in other places around the room different monitors. This is our Growlink monitor. This measures CO2, relative humidity, as well as temperature. Now, we just did a spray, so it's not quite in canopy as we would want. You would usually want it directly in canopy. Very important to notate, but that is where we're getting our metrics from. You'll also see in our core grow bags, we have moisture content sensors. So this right here will tell us the moisture content of our soil. It will tell us temperature and EC. And this is absolutely wonderful, being able to achieve instant data points of what's going on in the soil. Now, what's even cooler is that with this, having two per room, I'm actually able to run irrigation, crop steer with AI. So Growlink has a AI feature called Autopilot. You put in the parameters you want, and this sensor right here, and in my room specifically, the two sensors combined will give you updates, suggestions, and really walk you through the process of crop steering.
So I can separate in my case, it'll be rooms, but this could be according to zones or basically anywhere you have a control valve that can be switched on and off as you would any automated irrigation. So for each zone, we put, a name, the size pot, the, here I'm doing my two sensors that are averaged together. The valve you'll choose that you're wanting to control, the steering method you're currently in, your grams per hour, I'm sorry, your gallons per hour for your emitters, how many emitters, and then of course your lights on and off time. And then very important being your alerts in case there's any problems. In the schedule here, this is where it starts to make decisions for you. You're putting your ramp up time, starting about 30 minutes after lights on, the duration of that ramp up time, the interval and frequency, all of that is decided based off of your volumetric water content and what that capacity is for whatever type of substrate you're using. And then according to where you are from the prior day, it makes changes for um, every day from there on. Flush would only be if you have a flush valve. We don't have that, so we do not select to use it. This right here is what's really cool. It's the fail-safe feature. So instead of just being relying on a email or text saying, "Hey, your your root ball is getting very dry," this actually, once it gets to a certain value that you set, it'll go ahead and do an irrigation event. So again, if nobody's on site and you're not checking your email often, this is like a very safe feature to avoid absolute crop failure. So very awesome. And off of those decisions that are made via AI, you can actually see what this looks like for your day as far as your P1, P2, and P3 schedule, and what those suggestions are based off the day prior. Every day after your irrigation events have been completed and is able to gather that data from the sensors and plug that into the algorithm, it'll explain what the changes are and why. And so this is pretty cool and certainly a must-have for those who are trying to grow with crop steering in mind, and a lot more automated than pulling out a scale and trying to get that right every day.
Additionally, you'll see coming out from the table, not only do we measure what is coming into each plant through each emitter, but we also know what runoff is. We are measuring this every single day. So we know not only what is given to the plants, but what off is running from out of the plant. So we can accurately say, with X air velocity, you're using this much more water, which equates to this much more fertilizer, and really give a full picture of what's going on with this experiment. This, of course, is our high airflow treatment. You see a lot of leaf movement, too much air movement, in all honesty, but this is the purpose of the experiment. Thanks for tuning in with us. Please stay tuned to watch our journey with airflow research.